There are many areas in the world in which healthcare is inaccessible or expensive. Medical equipment can also burn through large amounts of electricity over time, causing landfills to be filled with dead batteries that take millions of years to decompose. To solve this problem, we are going to design a sustainable and cheap option for one of the most commonly utilized medical tools, the otoscope. Used by medical professionals to examine the ear canal and eardrum, the device relies on principles of biology to diagnose various conditions affecting hearing and balance. The otoscope allows for detailed observation of the ear's intricate structures, highlighting the importance of understanding biological anatomy and diagnosing ailments. Moreover, the use of 3D printing technology underscores the innovative approaches within the field of biology, where advancements in engineering and design enhance diagnostic tools, ultimately benefiting healthcare and our understanding of human biology. While building this project, we didn't run into many complications. We began by 3D printing some of the pieces and started wiring the rechargeable batteries to a battery holder and an LED light. We soldered a resistor into the wiring to ensure the bulb does not burn out. We temporarily soldered the hand crank motor to see if it works, but quickly identified a problem. Instead of the motor powering the batteries powered the motor and forced it to spin by itself. We solved this issue by soldering a diode into the wiring to ensure that the signal was only going in the desired direction. We then modeled a handle that could fit on the battery holder and the motor. We also installed a button to ensure that the light is only on when flying. Once all the wiring was correct, we put all our pieces together, glued them in place, and then tested the otoscope one final time. Aside from issues with the supports of the models, our final parts came out well and fit the dimensions that we had expected. While carving down the magnifying glass to fit the otoscope, however, the glass experienced light scratching that may inhibit the function of the tool. In general, our tool was able to be assembled completely and should work as intended. Looking back on this project, I believe that we managed our time well in both the choice of our project as well as our time during class. Despite the initial challenge of coming up with the design for this project, our group experienced a relatively small number of challenges. The electrical components seemed to come together seamlessly, and the wiring was accounted for in the 3D model. We're going to go back and redo this project. One change I would make is the location of the crank, as the current position may make it more inconvenient to hold, as well as be more careful during the glass cutting process, ensure that the glass is not scratched.